We can now develop a procedure to write balanced net equations for precipitation reactions. In the net equation, we will show only the ions that come together to form the solid. We've covered part of the procedure in the last module. When two solutions are mixed, the first thing to do is identify which combination of ions, if any, will form a precipitate. If a solid forms, then we need to determine its chemical formula. Finally, the new part here is that we will write a balanced equation, showing the ions as reactants and the solid as a product. As an example, let's write a balanced net equation for the reaction that occurs, if any, upon mixing 0.1 molar aqueous solutions of sodium phosphate and silver nitrate. Using the solubility rules, we find that the combination of sodium and nitrate is soluble and does not form a precipitate. We also find that the combination of phosphate and silver is insoluble and does form a precipitate. We recall that the charge on phosphate is 3-. We can determine that the charge on silver is 1+ because it is originally paired up with only one nitrate. Nitrate has a 1- charge. Then the chemical formula of the solid would be Ag3PO4. From here, it is only one more step to write the balanced equation. The fact that there are 3 silver ions in the solid means that we need 3 moles of aqueous silver ions in the equation. There is 1 phosphate in the solid, so we need 1 mole of aqueous phosphate ions in the equation. Of course, the product is the solid silver phosphate. Notice that once you determine the chemical formula of the solid that forms, it is only one additional step to write a balanced equation. You do need to pay attention to the bookkeeping, using the correct coefficients, the correct charges on the ions, and the correct states of matter. This corresponds to using the correct grammar and punctuation when writing a sentence. A note on using parentheses in chemical equations. Aside from the states of matter, there are no parentheses in this balanced equation. We do not put them around the phosphate ion on the reactant side. Even if the coefficient were greater than 1, we would not use them when phosphate is by itself. We do not put them around the phosphate ion in the product either. We would only use parentheses if there were more than one polyatomic ion present. There's not here. Note also that the charges must be shown for the ions when they are by themselves. However, charges are never shown in a neutral compound, even if it is made up of ions.